Now let's solve these questions. It is about the set associative memory, and here also the main memory is byte addressable, which means one word equal to one byte. That is the basic assumption. And now along with all the other parameters, I have even given you what kind of set associative it is, which means it is two-way. Okay, so this means two-way set associative, 4 means four-way set associative, 8-way, like this. Okay, so this is what is given along with the question. Now we are supposed to fill in the missing parameters. Now remember that we are talking about the set associative mapping. Therefore it helps if you remember how the address is actually divided. So if you are talking about the set associative memory, the physical address is divided like this. Okay, so initially physical address according to the main memory is divided into two parts. One is block offset, which is nothing but the word number within the block, and then the block number, right? So it's going to give you the word number and then it is the block number, right? This is according to the main memory, but then according to the cache, right? So block number is again divided into two parts. One is set number. So this part is set number, right? And this part is tag, right? So according to main memory it is block offset and block number, and according to cache it is set number and tag. So if you remember this, I think it will be easy to solve the questions. So first thing is main memory size is 128 KB and cache size is this, block size is this, and so and so. Okay, and now they are saying that it is two-way. So now whenever you have to find out the set number, okay, whenever I teach this subject in the classes, people get confused at one part. They think that if it is a four-way set associative, they think that the number of sets are 4. No, it is wrong. Four-way set associative means the number of lines in each set is 4. That is what you should be very, very careful about. Now, in order to solve this question, you should really be careful about one thing. You should find out the number of sets, right? Four-way set associative doesn't mean that there are 4 sets. I'll just take this example. Now main memory is 128 KB. So how much is physical address? Physical address is 17 bits, right? Therefore this entire part put together is 17 bits. And then cache size is 16 KB, block size is 256. Since block size is 256 bytes, okay? Since block size is 256 bytes, now what is the number of bits required for block offset? 256 is nothing but 2 power 8. Therefore number of bits required for block offset is 8, right? And now we know that this total number is how much? 17 bits. So this total number put together, this total number is actually given as 17 bits, which is nothing but the physical address. Now this part is given as 8. In order to find out the tag bits, we have to find out the set number. In order to find out the set number, we have to find out the number of sets, where number of sets present in the cache, right? So that is where I am going. Now I want to find out the number of lines in the cache. Number of lines in the cache equal to cache size divided by block size. How much is the cache size? 16 KB is nothing but 2 power 14 divided by how much is the block size? Block size is 2 power 8 bytes, which is nothing but 2 power 6 lines. Now I have 2 power 6 lines, and they are saying that it is two-way set associative. What is two-way set associative mean? In every set there are 2 lines. Totally I have 2 power 6 lines, right? The number of lines is 2 power 6 and one set contains 2 power 6 lines. See this, one set contains 2 lines, isn't it? So if I have to get 2 power 6 then how many sets are totally present? Number of sets present is 2 power 6 divided by 2, which is 2 power 5, which is 32 sets are present. If 32 sets are present, then how many bits are required to represent the set number? 5 bits, isn't it? Therefore set number can be represented using 5 bits, right? Then how many bits are required for the tag? Totally it is 17, and 8 plus 5 is 13, so 17 means 4 bits are required for the tag, right? So if you look at this, the tag bits are going to be 4. And now what about the tag directory size? That depends on the number of lines. How many lines are there? 2 power 6 lines are there, and each line is going to take each line is going to have 4 bits as the tag. So what is the tag directory? 2 power 6, 4 into 2 power 6 bits is the tag directory size. Got it? And now what about the number of comparators required for this case? The number of comparators required always is equal to the set associativeness, which means in here it is two-way set associative, therefore number of comparators required are 2. The reason is whenever you try to get into any search for any address, that particular block can be present in one set. Therefore you are supposed to get into one set, and in that set you are supposed to search all the lines parallelly. Now how many lines will be present? That depends on the k-way set associative. If it is k-way, then k lines, right? Therefore number of comparators required in set associative mapping is, in case if it is k-way set associative, then it is k. Since it is two-way set associative, then the number of lines present is 2. Therefore the number in a set, therefore the number of comparators are 2. Then what is the size of each comparator? Size depends on the tag, right? Therefore for this example, how many tags we need, comparators we need? We need 2 comparators, each size is 4, which means 2 4-bit comparators are required. That is what is required for this example. Understood this? Okay. Now let's look at the next one. Next one is saying that main memory size is 32 GB, right? So if its main memory size is 32 GB, then what about physical address size? 35 bits, isn't it? Then cache size is given as 32 KB, and the block size is given as so these numbers, let's fill them now. Okay. Main memory is 35 bits and block size is 1 KB. So 1 KB means 2 power 10, therefore block offset is 10 bits, that is fine here. And then cache size is 32 KB. So now we have to find out, in order to find out this part, this one is already given, the total size is given as 35, right? And in order to find out this part, I have to find out this part. So what is that set number? Now I have to find out this set number. That is why I am going to find out the number of sets, which depends on the number of lines, right? So now watch it. The number of lines in the cache is equal to cache size divided by block size. So cache size is 32 KB, block size is 1 KB, therefore number of lines is 32, right? And then after finding out the number of lines, you are supposed to find out the number of sets. So number of sets will depend on what is the way in which it is associated. So it is 4-way set associative, which means 4 lines are combined into one set. So if 4 lines are combined into one set, then how many sets can be formed using 32 lines? 32 by 4, which is 8 lines, isn't it? So 8 sets. So total number of sets present is 8, which is nothing but 2 power 3. So how many bits are used to represent the set number? 3 bits. So this is going to be 3 bits, right? And therefore it is 35 and it is 13. So how much is remaining, right? It is 22. So 22 bits are required for the tag. Got it? So this one requires 22 bits for the tag, right? And what about the size of the tag directory? Size of the tag directory depends on the number of lines and size of the tag. So number of lines are 32 and size of each tag is 22. Therefore 22 into 32 bits are required in the size of the tag directory. Got it? And what about the associativeness? So how can you find out the associativeness of the number of comparators required? The number of comparators required is based on the 4-way associative, means 4. If each set is containing 4 lines, now a required block can be present in any of these 4 lines. Therefore the number of comparators required is 4, right? And what is the size of each comparator? 22, right? So the number of comparators required is 4, right? And what about the size of each comparator? 22 bits, isn't it? So are you finding out the benefits? Earlier earlier when we had this that associative memory, associative mapping, then the number of comparators were very large. In the sense, here the number of comparators required were how many? That depends on the number of blocks. I think here 2 power 6, 64 comparators were required, but now only 2, right? And here how many were required? 32 were required, but here only 4, right? So depending on the way in which you are associating it, set associative, we are going to decrease the number of comparators required, right? Okay, now let's look at the next one. Next one is saying that main memory size is not given, cache size is given as 512 KB and block size is given as 1 KB, and it is 8-way set associative. So with this information, cache size, block size and the associative memory size, that that 8-way set associative, I can find out the number of sets, right? And what about this? Tag bits are given, right? So using tag bits, I can fill this part. Tag bits is 7 and then block size is given as 1 KB, which means this one is 10, and I have to find out the set number. Once I find out the set number, I can find out the physical address. Once I find out the physical address, I can find out the main memory size, isn't it? So how can I find out the set number? Then cache is containing 512 KB and each block is 1 KB. Therefore, the number of lines equal to cache size divided by block size. So what is the cache size? 512 KB divided by 1 KB, which means 512 is the number of lines. Now, which is nothing but 2 power 9 is the number of lines, right? And now it is a 3-way set, 8-way set associative. Therefore, number of sets equal to 2 power 9 divided by 8, which is 2 power 6, right? So 2 power 6 sets are possible. Therefore, which means 64. Therefore, how many bits are required in the set number? 6 bits. So here 6 bits are required in the set number. So put together, everything put together, we got the physical address, right? Now what is the physical address? 7 plus 6 is 13. 13 plus 10 is 23. Therefore, main memory size is 2 power 23 bytes. So how much is it? 8 MB. Got it? And what about the tag directory? If the tag bits are 7, then how many lines are there? Lines are 2 power 9. Tag directory size is 7 into 2 power 9 bits, right? Then how many comparators are required and what is the size of each comparator? So in this case, the number of comparators required are 8 because it is 8-way set associative, isn't it? Therefore, number of comparators required are 8 because each set contains 8 blocks and we have to simultaneously compare all the 8 blocks, right? All the 8 tags. Therefore, 8 comparators are required and size of each comparator will be depending on this tag size. So 8 7-bit comparators are required, isn't it? So 8 comparators are required and each comparator size is 7-bit. Without this set associativeness, if I have associative, then we need to have 512 comparators, right? Now what about the next one? Next one is main memory size is given and then block size is given and then tags are given, right? So we have to find out the cache size. It is interesting. See this? Now main memory size is given. Watch it. Main memory size is given. So main memory size is 16 GB. Therefore, what is physical address? Physical address is 34 bits, isn't it? Okay. And then block size is given. Therefore, what is block offset? Block size is 12. 4 KB means 12 bits, right? Therefore, block offset is 12 bits here, right? And then physical address, total physical address size is 34 bits here, right? And the tag is given, is it? Yes. Tag is given as 10 bits. Tag is given as 10 bits. Therefore, it is completely going to make up 22 bits. It is 22 bits, and if you subtract from this, it is 12 bits, is it? Yeah. So it is 12 bits. So this set number is going to contain 12 bits, right? 24, 34. Yes. So set number is going to contain 12 bits. Therefore, now we are supposed to guess the cache size. Now how can you find out the cache size? the cache size is equal to, I can write it like this, number of sets into number of lines per set into size of the line, isn't it? Are you following this? In order to find out the cache size, I have to find out the number of sets, and then I have to find out the number of lines which are present per set, and then I have to find out the size of each line. If I can find out these three, I can find out the cache size. Now what is the number of sets here? Number of sets is 2 power 12. And what is the number of lines per set? How many lines will be present in each set? So that depends on the way of associativeness, right? So it is 4-way set associative. Since it is 4-way set associative, right, the number of lines present per set is 4. And what is the size of each line? Size of each line is equal to size of the block, which is nothing but 4 KB, which is 2 power 12, isn't it? Then what is it? 2 power 12. 12 plus 12 is 24. 24 plus 2 is 26. Therefore, cache size is 2 power 26. So cache size is 2 power 26 bytes. You please cross verify one more time, right? I'm just doing it using my subconscious mind. So you please do it one more time consciously. I'm not sure whether all these numbers are right or wrong. Maybe there might be some calculation errors. Okay. And now what about this tag directory? At least in classrooms, what happens is whenever I do anything wrong, there will be some people to point out, but here there is no one to point out, right? So okay, so you do it. Okay. Now watch this tag directory. The tag size is 10 bits. Then how many lines are there? I mean, total number of lines is number of sets into number of lines, isn't it? The total number of lines is number of sets into number of lines, right? So how many lines are there? 2 power 14 lines are there, right? So tag is going to be 10 bits, and then number of lines into number of sets is 2 power 14, right? 10 into 2 power 14 bits. Are you getting this? Number of lines is 2 power 12, and then number of sets is 2 power 12, and number of lines per set is 4. Therefore total number of lines is 2 power 14, and tag size is 10 bits. Therefore 10 into 2 power 14 bits is the tag directory size. Okay. And now next one is look at these two questions. These are interesting. Okay, what about the comparators required? Since it is 4-way set associative, the number of comparators required are 4. 4 comparators required. And what about the size of each comparator? 4 comparators of size 10 are required, right? And what about the next one? It is, they are saying that it is a 64 MB. Yeah, main memory is 64 MB. Therefore, what can you say about physical address? Physical address is 26 bits. Therefore, this completely is going to be 26 bits, right? And then they are saying that the number of bits used in tag are 10, which means this one is given as 10, right? And nothing else is given. Okay. Now we are supposed to find out what is the cache size. So cache size depends on, I just told you, right? So cache size depends on many things. So one thing is so cache size depends on number of sets in set associative, number of sets into lines per set, isn't it, into line size. These are required. So line size is not given first of all, and then I cannot find out if line size is not given, I cannot find out the number of sets, and I cannot even find out the number of line per set, right? Nothing can be found out. So using the information given, I cannot find out the cache size, and I cannot find out the block size, because we have to guess these numbers, right? There is no way you can directly find them all. And if I don't have the number of lines, then I cannot find out the tag directory as well, right? And what about the comparators? Maybe 4 comparators are required, but I don't know. 4 comparators are required, and the size of the comparator will be 10. That one I can tell you, because the tag size is given as 10 bits, right? That is how I could guess it. So 4 comparators are required, and size of each comparator is 10-bit comparator. That one I can tell you, right? And the next one is cache size is given, which is 512. right? 512 KB cache size is given and tag bits are given. Tag bits is given and cache size is given, right? So now using this, I have to find out the main memory size. Now how can I find out the main memory size? If I could find out this total number, then I can find out the main memory size. In order to find out this total number, block offset is required, but block size is not given. Therefore, I cannot find out this number, isn't it? And then I cannot find out this number also, because in order to find out the number of sets, I should know the number of lines first. I cannot find out the number of lines, therefore nothing could be found out. I cannot find out the main memory, or I cannot find out the block size, and therefore I cannot find out the number of lines, and hence this one, right? But I can find out how many comparators are required. So 8 comparators are required and each size is 7. Got it? So in these two questions, some more data would have been helped, but since the more data is not given, we will not be able to find out much more about it. Got it? So this is how we could solve the questions on set associative memory. Okay.